For 5b, we're going to look at finding imaginary solutions. So we're going to use the quadratic formula to find solutions when we end up with the square root of a negative number. Okay, to finish up from last time, so we did adding and subtracting complex numbers, and now we're going to look at multiplying and dividing. So when we multiply complex numbers, it's distributing. It's just like multiplying polynomials. So 3i times negative 5 would be negative 15i, and then 3i times 2i would be positive 6i squared. And then here's the key part that you need to remember, is that anytime you have an I squared is equal to negative 1. So this is negative 15i plus 6 times negative 1, all right, or negative 15i minus 6. Okay, not a requirement, but most of the time you're going to see complex numbers written as a plus bi, so we would write this as negative 6 minus 15i. Usually the number comes first, and then the I term. Okay, so same thing here, we're foiling. We have to distribute twice, so 4 times negative 1 would be negative 4. 4 times negative 2i would be negative 8i. 3i times negative 1, negative 3i. And 3i times negative 2i would be negative 6i squared. Okay, so I have like terms here that I need to combine. So negative 8i minus 3i would be negative 11i. And then this I squared, remember, is equal to negative 1. So now I have negative 6 times negative 1, which would of course be positive 6. And now I have like terms that I need to combine. Negative 4 plus 6 would be 2 minus 11i. Alright, so I want you to pause here and go ahead and do example 3. Alright, next piece we need to look at is complex conjugates. Okay, so complex conjugate is the number that when I multiply it, it gets rid of the I terms. So the complex conjugate of a plus bi is a minus bi. So we're changing the sign of the I term. Okay, so here's your examples. The complex conjugate of 4 plus 3i would be 4 minus 3i. Okay, so here, 2 minus 3i, the complex conjugate would be 2 plus 3i. This is 4i, we're going to change it to negative 4i. So you always just change the sign of the I term. Okay, and the reason we need complex conjugates is to be able to do division. Okay, when you do division, that's what you do, is multiply by the conjugate on both the top and the bottom. Alright, so on the top, 9 times negative 3i would give me negative 27i. 12i times negative 3i would be negative 36i squared. Over on the bottom, 3i times negative 3i would give me negative 9i squared. Okay, so then both of these I squareds need to become negative 1s. Okay, so that means that now I have negative 27i, and then negative 36 times negative 1 would be positive 36, over negative 9 times negative 1 would be positive 9. And the last thing I'm going to do is simplify, so everything here can be divided by 9, and I would end up with negative 3i plus 4. Alright, over 1, but I don't need to write over 1. Okay, so that's the reason for multiplying by the conjugate, is it always turns the bottom, the denominator, into a whole number rather than something with I. So we can't have i's in the denominator in our final answer. Alright, so I want you to try example 2 here. Okay, so 7 minus 26i over 25, that should be our final answer, because those don't have a GCF, so we leave it just like that. Alright, so last thing is actually finding imaginary solutions. Okay, so here we have a quadratic equation, 2x squared plus 32 equals 0, and we're going to plug that into the quadratic formula. Now, there's no x here, so remember there is 0x, so my b is 0. So now, I go x equals, alright, so negative b would be negative 0 plus or minus the square root of 0 squared minus 4 times 2 times 32, and that's all over 2 times a. Okay, so again, the part under the square root is what we're gonna do all at once. So in my calculator all together, I put 0 squared minus 4 times 2 times 32. So I have, and I'm not gonna stop writing negative 0 because negative 0 is just 0. So 0 plus or minus the square root of negative 216 all over 4. Okay, negative 216, I'm going to break that square root apart because now that we know about imaginary numbers, I'm going to change it to the square root of negative 1 times the square root of 216. Alright, so the square root of negative 1 is I, and the square root of 256 would be 16. So I have 0 plus or minus 16i divided by 4. Alright, so 0 plus 16i would be 16i over 4. And then I also have negative 16i over 4. 16 divided by 4 is 4, so I have 4i or negative 4i, and those are my two solutions. Okay. Last example, I'm going to do number 4. Okay, so here's my a, b, c. Alright, x equals negative b will be as negative 1, so that would be 1 plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so 1 plus or minus the square root of negative 23 all over 6. Okay, square root of negative 23 we need to simplify, so I'm going to break it apart. Square root of negative 1 times the square root of 23, because there's no perfect square that 23 can be divided by. So the square root of negative 1 is I, so that simplifies to I square root 23. So my final answer is going to be 1 plus or minus I square root 23 all over 6. That cannot be simplified any further. So those would be my two solutions. Alright, and that is it for 5B.